Dits 2213, Operating Systems. Concept 12 titled Deadlock Detection. Under Lecturer, Dr. Nurul Azma Zakaria. By AMIRAH, PUTERI, AKMA and BALQIS from Section 1 Group 2. This is our team member's name and matrix number. Index for each page. 1. Deadlock Introduction, what is deadlock? 2. Real-life deadlock analogy, musical chair. 3. How can deadlock happen in operating system? 4. Deadlock detection, what is deadlock detection? 5. Wait for graph, how it works. 6. Back to analogy. 7. What happens after detection? 8. Key takeaways deadlock freeze system. What is a deadlock? A deadlock happens when two or more processes are waiting for each other to release resource, but none of them can proceed. They're all stuck, waiting forever. The real-life analogy for deadlock using musical chairs. 3 friends each need 2 chairs to win. They each already have 1 chair and are waiting for another. But, no more free chairs. As you could see on the animation, A has gotten 2 chairs, B has also gotten 2 chairs, meanwhile C has 1 chair. So, no one moves. No one wins. This is just like a deadlock. Everyone's waiting, but nothing progresses. How deadlock happens? Deadlock occurs when a group of processes is permanently blocked because each one is waiting for a resource that can only be released by another in the same group. This means none of the processes can proceed. There are 4 conditions of deadlock. Mutual exclusion, only one process can use resource at a time. Hold and wait, a process holds one resource while waiting for another. No preemption, resources can't be taken away, they must be released voluntarily. Circular wait, each process waits for a resource held by the next, forming a loop. Imagine you're using your phone, and you don't check the battery level while using it. You keep using it normally until one moment, the phone shuts down because the battery is dead. Only then do you realize the issue and charge it. This is like deadlock detection. You don't prevent the problem in advance, but once you detect it, you take action to recover. In operating system, when we use this approach we wait until deadlock occurs. Once it occurs, it gets detected and whatever recovery process is present, it is initiated. Then, the deadlock is removed from the system. The wait for graph. What is a wait for graph? It's a simple diagram that shows which processes are waiting for resources held by other processes. How wait for graph works. Each star represents a process, P1, P2, P3. Now, cycle, in this context. A cycle means a loop in the graph. In our example, the arrows go from P1 to P2 to P3 and back to P1 that forms a cycle. It shows that each process is waiting on another, in a closed loop. This is what causes deadlock.
Okay, let's go back to our cycle example. Let's look at the left side first. Everyone is waiting for someone else, and it goes in a circle. This creates a loop where everyone is stuck, nobody can move. That's what we call a cycle or a deadlock. But on the right side, one person is now waiting for a free chair instead of another person. This breaks the loop, so now everyone can take turns and the system keeps going. So the main idea is, if we break the cycle, things can continue working. Now that the deadlock is detected, the system needs to do something. Imagine this. 4 friends are stuck in a chair circle. No one wants to give up the chair, so no one can move. Suddenly, a 5th person walks in. First, the OS taps one player on the shoulder.
Oh no!
This is called termination, removing one process to free up space. Then, the OS looks at another player and says,
"Sorry, I need that chair for someone else."
What?
This is preemption, taking resources and giving them to others. Lastly, the OS pulls out a remote control, hits rewind, and time moves backward. Everyone goes back to where they started. This is called a rollback. Here are the key points to remember. First, deadlocks freeze everything. The system gets stuck and nothing can move forward. Second, detection is like noticing that freeze and doing something to fix it, like breaking the cycle we saw earlier. So, understanding deadlocks and knowing how to spot them is really important to keep things running smoothly.
That's all from us. Thank you for watching and paying attention.